evening. I'm Ramanand Krishnamurthy. I'm the Chief Energy Officer here at the University of Houston. And I wanted to take this occasion to welcome each of you to the third event in our Energy Symposium series for this year on critical issues in energy. Tonight's topic is transportation revolution, electrified, automated, who will lead? We have an excellent panel and a terrific moderator. You'll get to meet them in a few minutes. But before that, I wanted to thank a few people. I want to thank Centerpoint Energy for supporting this event as the presenting sponsor. I want to thank our media partner, Houston Public Media, who always, as always, have helped us spread the word and get you to come here. I want to thank a group of people here who are amazing. Evolve Houston. This is a group that came together about a year ago that is looking to transform the transportation in Houston, getting electric vehicles to come and be seen outside. If you walk outside, you'll see a whole bunch of electric vehicles. Evolve sort of created that. Evolve is a not-for-profit organization that is partnered by the City of Houston, Centerpoint Energy, NRG, Shell, and the University of Houston. And they have really been pioneering a new way to think about transportation in the City of Houston. I want to thank two groups of people who have really made this event possible. One is our President's Energy Advisory Board. These are people who are the C-level folks from across the energy industry, and these folks help us really figure out how best to organize our education, research, and outreach programs. The other group is my faculty colleagues. My faculty colleagues who are part of the Energy Fellows Program for the last 4 years, who have really contributed to the intellectual powerhouse at the university in areas related to energy. And I would be remiss if I didn't thank the student volunteers from the Energy Coalition who've been helping out tonight. You see them in the black t-shirts out there. They've done some terrific work to get you all situated here and be organized. So in case you've got friends and colleagues outside who are desperately missing this symposium, let them know that this is being streamed live on Facebook. They should be able to see the symposium. And if you ask a question or if you heckle, you get to be seen on it too. So don't heckle for that reason. We'll find out other ways to get you on. Video of this event will be found about a week from now on YouTube. Certainly share that with folks as you think appropriate. Last one, and this is a place where when you think about symposia and organizations like this, most people say silence your phones. Here I'm going to ask you to take your phones out and participate with questions for our panelists as well as moderator through a web link. We won't have hard questions, a hard copy of your questions, but we will ask you to submit those online. And you'll see that on that link there. So before I go any further, I want to introduce our colleague from Centerpoint Energy, Michael Conklin. Michael is the External Engagement Manager for Centerpoint Energy, which is an energy delivery company with regulated utility businesses in 8 states and competitive energy businesses in nearly 40 states. Michael is responsible for leading the stakeholder engagement and coordination for e-mobility initiatives across Centerpoint. And in 2019, Michael was Centerpoint's key person to co-found the Evolve Houston initiative. Before joining Centerpoint's Energy Government Affairs team, Michael Conklin had previously served as strategic planning and M&A lead during Centerpoint's 2018 acquisition of Vectren Corporation. With that, let me have Michael join you on the stage here.
Thank you, Dr. Krishnamurthy. I'm delighted to see so many people come out today on a Tuesday night for an advanced transportation symposium. And I know why you're here. It's because transportation is really important. It moves our economy. And modernizing transportation is a job for innovators. And in Houston, we are innovators. And Cougars are innovators. Go Cougs! You know, Houstonians care deeply about transportation. It's the #1 issue that people are concerned about, according to the Kinder Institute's area survey. It's where we spend 60 minutes every day commuting. And it's where we spend 16 cents of every dollar that we spend. It's where we spend almost 30% of the energy that we consume. And aside from housing, it's our biggest expenditure. It's literally where we're spending our time, money, and energy. Improving and advancing transportation is an opportunity that's ripe for innovation. That's why I'm excited to hear our speakers talk about autonomous vehicles and how they'll reduce our commute times, high-speed trains and how they'll move us quickly between business centers, and advanced electric vehicle fueling infrastructure that'll go from the road to the road, moving us seamlessly across our highways on electric charging lanes. These advanced transportation technologies all benefit from abundant, clean, affordable electricity. CenterPoint Energy's electric grid is an advanced energy delivery platform that powers more than 200 million miles of electric vehicle driving every year. Through this platform, CenterPoint Energy customers enjoy access to smart, clean, convenient, and reliable electricity for all their electrified transportation needs. And with over 80 electric vehicles and about 40 charging stations, CenterPoint Energy is proving electric vehicle technologies in its own fleet today. I'd like to commend the University of Houston, Dr. Krishnamurti, Dr. Greg Bean, for continuing to lead our region's transition to modern energy and transportation by convening important conversations like this one today. I'd like to thank Houston Public Media for joining CenterPoint Energy in sponsoring this symposium. And I'd like to give a special thanks to Evolve Houston for their sponsorship and leadership in advancing transportation in the region. Evolve Houston is a coalition of sustainability-minded civic, business, and academic leaders who seek to accelerate modern transportation through electrification, with board members that include the City of Houston, University of Houston, Shell Energy, NRG Energy, and CenterPoint Energy. Evolve Houston is leading Houston's transition to new energy vehicles. Evolve Houston is a great example of world-class solutions by Houston for Houston. Together with Evolve Houston, CenterPoint Energy is working with consumers, businesses, academic institutions, and governments to show that electrified transportation makes good business sense for Houston. Next, I'd like to welcome our moderator, Dr. Greg Bean. Dr. Bean is the Executive Director of the Gutierrez Energy Management Institute in the Bauer College of Business at the University of Houston. Prior to joining Bauer, he was previously an oil and gas strategy and organization consultant as a partner in several management consulting firms. In these roles, he served international, independent, and national oil companies for over 30 years, leading numerous projects including major corporate, business unit, and capital investment strategy assignments and organization restructure efforts. All of this started with his career at ExxonMobil. Dr. Bean is a graduate of Texas A&M University, but he got to UH as fast as he could. Please welcome Dr. Greg Bean.
Hi, good evening. We have an excellent set of panelists to get to, and I'd like to get to those pretty quickly. I'll introduce them all in a moment. Before I do that, I thought it would be helpful to provide just a little bit of context for the topic. The topic being the transportation revolution. Okay. Sorry, I'm having a little trouble with. Oh, there we go. Thank you. And really starting with why are we talking about a transportation revolution? And the fundamental driver for that is the fact that we are in an energy transition. It's being driven by a number of factors that will evolve over the next 20 or 30 years. And a number of them are listed here. It has to do with improving access and energy security to a growing population in the world, climate change, which we'll talk about in a minute, as well as other impacts associated with energy production and use, air pollution, and other ancillary effects. Climate change is probably the biggest single driver of the current energy transition. Many of us are familiar with the specifics of this. Human activities are estimated to have already caused an increase of about 1 degree C in the average global temperature above pre-industrial levels, and global warming is likely to reach between 1.5 and temperatures likely to increase by 1.5 or 2 degrees without a change to our energy systems. The implications for that we've all heard about, having to do with higher mean temperatures, more hot extremes, changes in precipitation, more droughts. And the key for us, and the reason why we're talking about this, is the requirement that in order to limit the temperature increase to levels that would be manageable for us, we need to reduce net CO2 and other greenhouse gas emissions by significant levels. Hence, we really do need a revolution. So we're talking about transportation here. We're talking about transportation because transportation is responsible for about a quarter of all greenhouse gas emissions, as you can see here. And while we're talking about all forms of transportation here, as you'll see, a particular emphasis on road transportation is warranted given that the majority of the greenhouse gas emissions that come from transportation actually come from road transportation. And finally, if we look at the projected growth in transportation energy demand, there is a lot of progress being made in energy efficiency. But the gains in energy efficiency will be insufficient to reduce the total transportation energy demand to the levels that we need to limit greenhouse gas emissions and hence global temperatures to an appropriate level. So we are looking for radical potential solutions to fundamentally change our transportation energy system. And our panelists here, all four, each represent a fairly unique and potentially high impact part of that solution to that revolution. Oh, sorry, get mixed up here. Our first panelist is Norm Whitten. He is the managing director of the Electric Interstate Highway Standards Association. Norm is an entrepreneur and the managing director of the Electric Interstate Highway Standards Association, which is a 501c3 nonprofit that encourages people to adopt electric vehicles. He's active in Evolve Houston, which Michael just described, a consortium for encouraging adopting electric vehicles. His companies provide solar PV installation, as well as other businesses, including clothing recycling, and fitness services. Formerly, he worked for 3 decades in the oil and gas industry, including 12 years as a management consultant headquartered in Houston and Singapore, and 3 years in algae to crude oil research. Norm holds 2 patents and earned a degree, an MBA degree from this fine university. Next, we'll have Holly Reed. Holly is the Managing Director, External Affairs for Texas Central. Holly's role with Texas Central has been a continuation of her career, working on transformative projects in critical infrastructure, focused on the potential offered by a high-speed passenger train connecting Greater Houston and the Dallas-Fort Worth Metroplex, the fourth and fifth largest economies in the country. Holly previously worked at AT&T, where she served as a regional vice president and helped facilitate network deployments of high-speed internet, mobility networks, and communications infrastructure. At Texas Central, her responsibilities include public policy, outreach, government relations, and branding, media, and communications. Holly is a native Texan, and she earned a bachelor's degree in business from Texas A&M, the other fine university in the state of Texas. Next, we have Shola Lawal. He is the product operations manager for Neuro. Neuro is a California-based robotics company. He works with Neuro's local partners, including Kroger, to manage delivery operations in Houston, where he's based. Shola oversees community outreach to educate residents about the company and about its fleet of autonomous vehicles. Some of you may have seen some of them around different parts of the neighborhood here in Houston. He previously worked at Uber, managing operations in West Africa and the United States, and served in a number of engineering roles at Dow Chemical. Shola has a bachelor's degree in chemical engineering from Rensselaer and a PhD in entrepreneurship and strategy from Indiana's University's Kelley School of Business. Finally, we have Anita Sengupta, who is the co-founder and chief product officer of Airspace Experience Technologies. Dr. Gupta is an aerospace engineer, real rocket scientist, and pilot. She spent 16 years at NASA, where she led the development of propulsion and landing systems for deep space, Mars, and Earth reentry. She later served as Senior Vice President of Systems Engineering at Virgin Hyperloop One, and is currently co-founder and Chief Product Officer of Airspace Experience Technologies, an aviation technology startup that is developing an electric-powered vertical takeoff and landing system. Anita received her master's and PhD degrees in aerospace engineering from the University of Southern California, where she is a research associate professor of astronautics, if I got that correct. So I'm sure you'll enjoy hearing on some of these very interesting and exciting things from our panelists, and we'll start with Norm Whitten, please.
Thank you for that introduction, Greg. I appreciate the opportunity to come and see everyone today. It's wonderful to see such a large group of people. Since you had trouble with this, I'm going to have real trouble, right? Not that button. There we go. Okay, everybody here today probably rode on an interstate highway, I'm guessing. Unless you happen to live on campus, everybody in Houston goes on an interstate almost every single day. So we're all familiar with this technology. It was first started in 1920, the first plans. People think it was Eisenhower, but it was actually well before him. So what's great about the interstate? Works great for us today, sort of. But we need Interstate 2.0 with new technology. Faster, cheaper, greener, and safer, and more entertaining. But I couldn't fit all that on there. All right. That wasn't the button. There we go. There's some slow. So I'm going to talk to you today for only 10 minutes. It's a huge topic. I'm going to focus a little bit on reminding everybody what the interstate system is and some key facts about it. We're going to talk about new vehicle adoption, electrification, and autonomy. We're going to hear more about autonomy later, but we're going to talk about it on the freeway. Challenges and improvement opportunities. Everybody who drives on it and has an hour to think about it every day has their own pet peeves about it. We'll talk about some of the real opportunities to make it much more useful. We're going to talk about an integrated roadway concept that's being tested by Siemens, a German electric company. And we're going to talk about what I think technology is needed to adopt that concept for US. Might happen, might not. We're seeing a lot of innovations happening in this space. Okay. Interstate highway system, 48,000 miles of concrete, covering about 800 to 1 million acres. We don't have exact numbers on that. The states actually own the right-of-way. That 800,000 acres, 800,000 to a million acres, could produce, if we put solar PV on it, 8% of the US consumption of electricity. So we're using land right now to hold up concrete and not do other stuff with it. There's an opportunity there. It carries 43% of US truck miles. Okay, that works out to about 66 billion miles a year. The majority of the highway use is in town. So about 2/3 is urban, 1/3 is suburban. Keep that in mind when we think about how we're going to use electric vehicles on that road. Let's go to the next. Yes, that worked better. What we're seeing with battery electric vehicles, anybody here besides a few of us we have a few who are driving electric vehicles. We're going to start seeing many, many more electric vehicles coming into the marketplace because electric battery costs as a proportion of the cost of a car have come down dramatically. Bloomberg News has estimated by 2023 there will be parity for a medium-sized car. Capital cost for an internal combustion engine versus capital cost for a battery engine will be the same. But electricity is way cheaper than gasoline. So the actual cost of operating your vehicle as an electric vehicle will be considerably less, and we're going to start to see that driving a large increase in the number of cars that are sold as electric vehicles. Trucks, not so much. Why not? Because trucks require a lot more batteries, and batteries are heavy, and it causes an issue with the load capacity. Talk about that next. Okay, in order to have an electric vehicle, you have to fuel it. Most fueling for electric vehicles is going to be done in its domicile. So if it's a truck that's at a terminal, it will be fueled at the terminal, charged at the terminal. If it's at your house or your apartment, it's going to be charged at your house or apartment or at your workplace. However, on the interstate, you don't have a house or an apartment or a domicile, you need charging. And you can see 3 major charging networks already in the US that are located along interstates. The challenge with interstates is we need faster charging so that we can put those vehicles out. And the problem with faster charging is, you'll notice we have CenterPoint here talking about their grid. As you have higher and higher rates of charging, you put more and more stress on the grid. So what that requires is some method of storing energy to feed into those charging systems, which means even more batteries. And that's a challenge with making this transportation transition, is bringing those batteries in place. Next, please. The other major technology that's happening is the change in who drives the truck or who drives the car. So autonomous vehicle adoption over the last 3 or 4 years, we've seen technologies coming out. I believe today we actually have highway trucks that are being driven autonomously. They're not publicized because people don't want to have, truck owners don't want to have people vandalizing or causing troubles with those trucks. They're often being done with safety drivers, but increasingly we're removing safety drivers from that segment. Urban cars, much, much more difficult. People are pretty finicky about how they want to be driven around. A box in the back of the truck, not so much, right? So we're going to see urban cars and taxi services later, and we're going to hear Shola talking about a package delivery service urban. Urban is hard. There's a lot of complexity. What's driving all of this change? Okay, according to the American Trucking Association, it costs almost $2 a mile to drive a truck down the road. 2/3 of that cost is the driver and the fuel. This is diesel fuel. Diesel fuel is expensive. Electrons are about 20% of the cost. So electrification is an important move for trucks to move toward. Driver costs are 40% of the cost of driving, going down the road. So if you can reduce that, there's a very significant improvement in value. Okay, let's go to the next. What are the adoption challenges for these 2 new technologies, electrification and autonomy? One of the biggest problems is the availability and cost of batteries. Currently, manufacturers, OEMs who are wanting to make electric vehicles find that they're having a shortage of battery facilities. There are very few EV truck models available to purchase today. If you called up Peterbilt and said, hey, I need an electric truck, they're going to say, hey, talk to me in 5 years. So we have to get batteries out so that we can build these pieces of equipment. Because of the cost of those, the costs of the vehicles are high. And we're going to have to work on grid power capacity to provide high-speed charging, megawatt or 2 megawatt scale. That's challenging for grids to put up. The other last piece here, we have to have public acceptance of EV and autonomous vehicles. Generally speaking, we find that if you have a technology that is 30% better on some dimension or set of dimensions, it becomes rapidly adopted. We already know that the operating cost and the ease of use and the low maintenance requirements of electric vehicles is driving that. We know there's a huge savings to be had in reducing the cost of drivers. So those weights are starting to move people toward acceptance, and we're going to start seeing very rapid adoption of these technologies. Moving forward to the next, what are the problems that we still have remaining, or what opportunities are there? Can I go to the next slide? Thank you. Because we have to have batteries on board as well as on land in order to provide the charging, that wastes money. We lose payload because of the battery weight in trucks. There's time wasted in charging. There's a whole bunch of time in our interstate where we hardly use them. Anybody driven on the interstate at about 3 o'clock in the morning? It's not very much traffic there. We have human limited driving capacity. How fast can you drive? I know when people go to Dallas, you want to drive 90 because everybody else is, but you're not supposed to because it's not safe, right? But what if we had autonomous vehicles that could drive at 140? Would that be interesting? Potentially. I'm seeing some grimacing over here. Okay, not today, but maybe in the future we'll have that capability. We have 800 to 1 million acres of land that is doing nothing but holding up concrete when it could be generating revenue by making electricity. And we have a failed fuel tax revenue model, meaning that we're going to bust our highway transportation fund mechanism because we won't have fuel taxes. EVs don't pay fuel taxes. So we're going to have to change that in order to continue to have our interstate highway system. What can we do? Deliver power directly to vehicles on the highway. That's a really different concept. We need to integrate AV to have full platooning, full control. And we need to produce and sell electricity from this giant amount of public assets that we have that we're underutilizing. So what might that look like if you put all that together? It might look like this. Something where you have a integrated highway concept, where you have in dedicated lanes, autonomous high-speed electric vehicles like cars traveling as fast as you really want to go to Dallas. That's 20 years down the road, folks, not coming in the next 5. You want to have autonomous electric trucks powered by wires on the road so you don't have to have batteries in them. That could happen faster. You want to have some type of solar canopy so that you're generating power off of the right-of-way. Maybe it doesn't actually go over the road. Maybe it's just on the shoulders on both sides to begin with. But we need to generate more value out of the land that we have. What does this look like in 3D? Maybe ugly to some, maybe different to others. But if you're riding in that vehicle and you're not driving it anymore, probably you're going to be playing your entertainment systems inside. You're going to be moving under the control of something where it's very safe, very fast, very energy efficient, and very green. So this might be a way that we could look in 20 years or more from now. Next, please. Those technologies are being tested. I've got here, Siemens have tried this for a couple of years. I don't know how to turn this on. Can you run this, please? Okay, technology. There we go. They got some fancy music here too. Okay, it looks like a train except it's a car, and I'm sure some of the same technology is going to be used here. But for the highway, in my view, this technology is not the right technology to go. There are some changes that we can do that will be making it even more effective and cost-effective. So the last slide I have here, oh, that went the wrong way. Okay. The catenaries are a problem. Those wires have to be replaced about every 10 years, and they're expensive. The pantograph weighs 2 tons on a truck. You can't waste 2 tons on a truck. Why do that then? So we need something that has a U-channel that you can connect like this to take your electricity from, rather than a set of wires that you have to push hard against and grind against in order to make the electrical connection. You need a drone to lift the connection up from the truck rather than a 2-ton large piece that we showed. Solar canopy needs to be really light, composite, strong, able to withstand wind. Energy efficiency is being worked on. Current solar PV is 20% efficient at converting solar inbound radiation to electricity. In 5 years, it will be 30% as a result of changes in materials. Autonomy, faster, closer spacing, requires new algorithms, faster computing capability. And importantly, and most difficult probably for the United States, we have to have a public-private partnership that works with this, and the public part of it is hard. So that's where we need some innovation, right? And everybody who drives on that, using those pieces, needs to have some standards, which is why we set up our nonprofit to help people focus on that. Thanks for your attention.
Thank you, Norm. Next, we'll have Holly, who has a slightly different perspective on the Houston to Dallas problem.
Slightly different, yes. We will be, though, the largest electric vehicle in transportation once we're up and running, so yay, Texas Central. All right, I'm going to start by saying, how many of you have driven from Houston to Dallas? How many of you enjoyed it? I'm done. This is an interesting project because it operates in some rare air. We operate in actually solving a problem, and the technology just happens to come along with it. So we will be the right project, being done the right way, finally at the right time, and I'll talk about all of those things. It is a challenge to go through a big project like this in 10 minutes or less. I've got several slides, so I'm going to blow through them very quickly. We'll just say at high speed. And hopefully you'll give you a flavor for what we're doing and how special it is, and how proud I hope you are that it's being done right here in Texas and serving Houston. It's the right project because it's here intentionally. We looked at over 90 pairs of cities to determine where in the United States will a high-speed train be most commercially successful. Commercial success is important because this is not a government project. It is being funded by entrepreneurs and investors and not your state or federal government. So it is the right project because it's here intentionally. There's roughly 7.5 million people in the greater Houston area, roughly 7.5 million people in the North Texas area. Connecting them is a market, and again, we're solving a problem. It's the right project because it's here. There's only 500 feet of elevation change between Houston and Dallas. Straight, flat, no mountains, no tunneling. The engineering challenges are considerably less, and the market share and the ridership is there, so the market works. So it's the right project being done the right way, which means being driven by the entrepreneurial spirit and the big ideas that only Texas can bring to you. And it's finally the right time. There is value in being a clean alternative to connecting these two communities. There is value in your time and saving time. And there's also the right time because we finally realized that freedom has a new definition. It used to be, I can drive my, we'll just say truck, because it's Texas. I can drive my truck wherever I want, whenever I want. Now it's, I choose when I drive and when I don't, whether it's rideshare, taking a train, taking public transportation, or driving. And that is why this is so important. We're getting farther apart, not closer together. So how do you then, once you decide to do this, how do you connect the dots of these two metropolitan areas? Well, you pick the best technology possible. So what we are purchasing is the Shinkansen N700S. from Japan Central Railway. It started its first operation in 1964 in advance of the Tokyo Olympics. And guess what? The newest generation of train will be debuted in July in advance of the Tokyo Olympics this summer. So we're getting the new train. In all of that time, there has never been a fatality or an accident as a result of operations. Very safe, safest way to travel in the world. And you will be able to get from the Northwest Mall area to just outside of downtown Dallas in 90 minutes, on time, every time. And I'll tell you why I say that so confidently. Again, this is based on a business plan that makes sense. We have spent tens of millions of dollars understanding what you want as a rider in that ridership experience, how to make it comfortable, safe, and reliable. And we've spent money understanding who makes that trip. 16 million trips are already being made every single year. 2 years ago, that number was 14 million. So with the growth projections that we see in Texas, in these communities, we know that that number is up and to the right. And you all have told us that you would ride it if it's available. The station I mentioned here in Houston is the old Northwest Mall space. So we're in the sweet spot of serving all Houstonians. We're close to the Galleria, close to downtown, the medical center, to the energy corridor, the university. It will be a really good location to go to all of those employment centers. So how do you build this? As you heard earlier, some of the biggest challenges are, since it's never been done before, this will be the first one in North America, we get a lot of special attention from our federal regulators. We also have to create a workforce, we have to create a supply chain, and we have to create the ability for success. And so these are just some of the milestones that we have reached over the last couple of years. From a federal regulatory perspective, the reason that that's important is because that sets the pace at which we can start construction, start operations, and you can ride the train. In December of 17, the Federal Railroad Administration released their draft environmental impact statement. It's a 5,000-page document plus. That tells us how to connect these two major metropolitan areas, which are the fourth and fifth largest economies in the country. We all just happen to be in Texas. How do you connect the dots with the least impacts on the environment and communities? And so that document is being finalized, and we hope to have all of the environmental process completed by this summer. I'll talk a little bit more about what that path looks like in a second. The other thing that we have to do is we have to get a safety regulation, set of regulations for how to operate a train at 200 miles an hour, taking you up and down safely every single time. We'll leave every 30 minutes during peak times, maybe every hour off peak times, possibly running more frequently if there's an Aggie football game, because the only stop in between is right outside of College Station. I don't know why you would ever want to go there, except for maybe a couple of us, but it'll be an option. So the rules are going to be different because you are going 200 miles an hour. Because it is dedicated to this train only, you're not mixing with heavy freight trains, it's brand new right-of-way, brand new tracks, and we never cross a road at grade. So that means you really have to think about a train and a system differently. Quiet, light, energy efficient, runs on overhead catenary. It's a very clean alternative. So again, I mentioned you also then have to build your project from scratch, but you also have to build your knowledge workers. These are only some of the companies that have already been working on this every single day. That's the civil constructors, our technology, and the technology we're bringing is not just the train cars, but it's the signaling systems, it's the overhead catenary, it's all of the pieces that make it operate, making sure that we bring the safest system in the world here to be operational just like it is in Japan. We announced most recently that Mass Electric and Kiewit, Kiewit's a subsidiary of Mass Electric, they'll actually do the installation of that system onto the civil infrastructure, and then the operations will be done by Renfe and Adif. These are technology partners that are the best in the world. Renfe is actually the second largest railway operator in the world. The only one larger is out of China. Salini and Lane have built railways all over the globe in different countries, different technologies. They'll be doing the civil infrastructure from the ground up to the rails. That's about $14 billion on a total of about a $20 billion project. And then we've got Bechtel, who's program managing this to make sure that we're on time, on schedule, integrated, and efficient. So I'll go very quickly. This is some of the materials that go into this project. You can see there. How will it be funded? Again, it's not funded through federal grants. It's not funded through state appropriations. It is funded by the private sector, and there's a lot of infrastructure investment out there to be had. Hopefully, some of the students that are in here will be coming to work on the project because we're going to need 10,000 folks to build it. And then when we're fully operational, we'll be 1,500. Roughly a third in the Houston area, a third in the rural area, and a third in the greater Dallas area. Again, the environmental process that we're going through tells us that this is the preferred alignment from the Federal Railroad Administration. You'll notice that coming out of Harris County, it gets really straight for a long time. Most of the alignment is adjacent to high power lines, pipelines, things that are already there in the right-of-way, which makes it pretty handy when you're an electrically powered train. Actually, 4 of those counties that you see there are already in air quality non-attainment status. So having an alternative that is clean will help mitigate the air quality problems and the pollution that a growing state like ours is seeing already. Again, this will be the cleanest way to connect the communities between Houston and Dallas. And not only is the technology ever evolving and getting better and better, but the regenerative braking and the safety technology is getting better and better. So every time the train starts to stop, it puts energy back on the grid, about roughly 10% of what we'll be using. Here's a couple of statistics around what we're actually going to be using on the grid. During acceleration, we'll be at about 12. When we're cruising, we'll be obviously less than that. And that regenerative braking is key. We'll have a $36 billion economic impact over 25 years. In Texas, we measure economic impact over Super Bowls. So not only will it connect communities, not only will it drive a better, cleaner way to connect people, but we'll be driving economic benefit. And yes, that is 84 Houston Super Bowls. Thank you very much. And we will be creating a new economy that'll be based right here. And people are really excited about the project. This is just a small number of groups that have been supportive of making sure that this happens here. It's a very, it will have you in mind as how you want to be connected between these two communities. And I'm going to show you a quick little video, I think it's a minute and a half, that will show you your different experience of getting between Houston and Dallas. Again, because it is no at-grade crossings, because it is dedicated, we know that you will leave and arrive on time every time. And so maybe it's not on there. Okay, you don't get the video. So I'll tell you what the ridership experience is. How many of you have ridden a high-speed train? All right, keep your hands up. How many of you have ridden a train in Japan? So if you don't believe me, come see these people afterwards on how exceptional that experience is. You can balance a coin on its edge at 200 miles an hour, pass another train, and it doesn't fall over. What does that mean? That means that you can get up, you can walk around. That means that you can work. You don't have to wait till you're 10,000 feet to turn your laptop on. That means that you will have a very comfortable ride. There are no seat belts. You don't sit on this hard metal object like on an airplane when you sit down and have to move it. And no middle seats. As a matter of fact, what we have designed is in one configuration, it's 2-2, and in the other configuration, it's 2-1. And so you'll have the ability to be very comfortable, and it will be exceptional. The aisle, it's the widest train set, passenger train set, and so that means that you have a lot of room for Texas-sized, we'll say, shoulders. The seats are bigger. The aisle is so big that a wheelchair can go up and down the aisle, so it is a game changer for those people with disabilities. And when you build a system with the people with disabilities in mind, we all benefit. Yep. And because the disability community can decide whether they want to stay in their chair or get out of the chair, that means they can choose if they want to even have a helper join them or not. It really will be a new level of freedom, as I mentioned at the beginning of my comments. As a matter of fact, in our ridership studies, coming to Houston for healthcare showed up as a reason that people wanted to ride the train. So it's an important accomplishment for our country. It's an important accomplishment for Texas, and we're very proud to be bringing it to you right here in Houston.
Thank you, Holly. And I just want to remind everybody in the audience that we have the ongoing questions to be submitted, so please take advantage of that opportunity and pose some interesting questions for all of our panelists. Our next speaker is Shor.
Thank you. And it's wonderful to be here. Both of my parents, as well as a few siblings and many friends, attended this fine university, and I have, on occasion, sat in on philosophy and business classes, and so it was nice to be a student here a bit without the student loans. That's always nice. So I'm here to talk about self-driving vehicles, particularly neural self-driving vehicles. But before I get into that, sort of a broader portrait. All of your favorite car companies, as well as a few companies that you've probably never heard of, are all interested in autonomous vehicles and self-driving cars. And the question is why? What is the benefit that you actually get from these autonomous vehicles? And as you have these conversations, three things typically come up. So one is safety. I don't have to stress, Michael spoke a bit about the safety hazards, as did Norm, of driving on the road at 90 miles an hour. And Texas does lead in vehicle fatalities, with the Houston area having quite a few every year. And so I'm sure most of you who drive here in the city understand exactly why safety is paramount. Accessibility, so getting around, the folks who may not have the access to getting from point A to point B due to restrictions or impairments will be able to do so with this. And the last is convenience. So the folks who maybe have no impairments but still need to get around will be able to do so as well. So if you think about the teenagers, the elderly, they will be able to get around from point A to point B as well. And all of that is great. And we are very large fans of the benefits that self-driving cars can bring. But our co-founders were early at Waymo, and they had been there for a long time. And Dr. Gupta, when she comes up, mentioned something that really sort of struck a chord with them, which is autonomous cars are great, but they're probably a little bit away, right? Like every car maker and the folks that you've never heard of who are working on self-driving cars have said that they were going to launch a vehicle, and then that date has been pushed back just a little bit every year, right? And so that's a bit of a challenge, and they said, you know what, we think that we can make self-driving cars happen, and we can make them happen really soon. And as they thought about what they could do, they decided that they would take on a completely different market, right? And so they built this cute little bad boy here, which is a driverless, passengerless, last mile delivery vehicle. So it is unmanned, and it will bring your favorite items to you. We have partnerships with Kroger, Walmart, and Domino's to bring your grocery as well as your hot food, hot pizza, to your curb for you to unload. So why this, right? Like there are a ton of different potential autonomous applications, but our co-founders decided to look at this. And there's a few reasons. So congestion is a major reason. If you think, and this particularly applies to Houston, we can talk a little bit more about why. If you think about the amount of time that you spend on the road that Michael mentioned, 60 minutes every day, and then spending another 10 or 15 minutes to get to the grocery store or to pick up pizza, we are really looking to, one, reduce congestion by not having you spend that 10 to 15 minutes on the road, but also by batching. So everyone is going to the grocery store, everyone's looking for a parking spot, and what we want to do is say, you know what, why don't all three of you stay home and we will bring all of your groceries in these separate compartments. Environmental is the reason why I think I got an invitation. And that is because these are self-driving electric vehicles, which from the outset really made a lot of sense. Norm talked about how much energy prices for electric vehicles has decreased. And when you have a really massive fleet, those differences and that CapEx reduction actually means quite a bit for the bottom line. And the last thing is local commerce. So I mentioned the really large national and international partners that we have today, but ultimately the goal is to build a platform where anyone who wants to deliver anything can essentially call a Neuro vehicle, load the vehicle up, and have that vehicle drive to their customer. So for us, we really are looking at things in a different way and looking to establish and essentially upend the model of how people run errands today. So it's also a really big business opportunity. I think we've heard a few people say we are not federally funded. We are essentially not looking for any money from the government. The reason why this is so fascinating for us is because if you look at the number of, or the percentage of miles that people spend on the road today, 15% is generally that commutes, probably a little bit larger for those commuting in Houston, but 43% is running those errands. That's the grocery store, it's the post office, the florist, it's the dry cleaners. A lot of what we do in our vehicles is actually going to pick something up, and that is a massive opportunity for us to essentially take that off of your hands and provide more convenience in your lives. And so as we think about what we're really looking at in this space, we've got grocery and food. We're also looking at retail, local services like the florist and the dry cleaner, as well as prescriptions. And we think that there are numerous possibilities that don't currently exist because really this model would be very new. So take the example of a farmer's market in a neurobot, or even a vending machine that could provide some of your last minute needs, and potentially a whole new ice cream truck, right? So there's quite a few things that we could do with this once we get it on the road. And so that's sort of at a high level, but I don't want this to be high level. This is very real. It is very real right now. We are operating in Houston right now. And so I just want to talk a bit about the operations that we currently have in Houston and what we're doing and what to expect over the next few months. So we are currently operating in 6 zip codes across the Houston area, West University, Southside Place, Bel Air, a little bit of the Heights, and we operate from 3 different Krogers, and we are looking to launch our partnerships with Walmart and Domino's here over the next few weeks. And for us, that next phase not only includes the new partners that we've announced, but partners that we have not announced, expanding with the partners that we have currently, and introducing R2, which is our second version of the robot. We're not necessarily the most creative outside of building the autonomy software. So we had R1, which launched in Scottsdale and has done thousands of deliveries. We are building, and R2 is now here in Houston, and we'll be doing deliveries in the next few weeks. And that is it. I believe there will be time for questions after this.
Right. Okay, great. Thank you. Now we'll have Anita as our last speaker before we move to questions.
Thank you for having me, everyone. And I've been to Houston. I'm so short, so maybe I'll stand over here. I've been to Houston so many times, traveling down to JFK.
Pointless to talk without the microphone.
Oh, is my speaker not on? Oh, so these don't work?
Should be, yeah.
Oh, okay. Sorry, that was a very extreme response to that. So thank you for having me here. And it's my first time to actually Houston proper and to your wonderful university. I'm based in Los Angeles, not Houston, so I've been learning a little bit this evening about some of the local challenges related to transportation in Houston. But what I'll present to you today related to urban air mobility and electric aviation is a global challenge and a global solution potentially. So what you can see in the graphic behind here is our new aircraft design, which is called the Mobi 1 or Mobility 1, and it's a new type of aircraft, which I'll show you briefly in a video. My company is based in Detroit, Michigan. There's a very specific reason for that. The automotive sector does a really good job at producing high reliability vehicles, now shifting over to electric vehicles at a very affordable cost and in mass production quantities. So if urban air mobility becomes a new form of transportation for urban, suburban centers across the world, then having the ability to do things at mass production in the way the automotive sector does it can be quite beneficial to the space from a business perspective. I'm co-founder of the company and also a corporate officer, and my background is all related to engineering. And specifically, I spent the majority of my career in the space program, and I'm a huge fan of science fiction, and so you can see a lot of relationship between some of the technologies which have been proposed in the science fiction regime becoming a reality, whether that's ground-based travel, air travel, or space travel. So I'm a pretty big fan of that. And ultimately, I think somebody opened up with the fact that Houston is a center of innovation. Certainly, many different urban centers across the world are a center of innovation. And when you see innovations in transportation, oftentimes they do happen in the entrepreneurial space as opposed to the big corporate entities. So a great example would be Tesla really has pushed forward electric vehicles, and now all the other automakers are following suit. And the same would go for aviation, where there are many small companies now in this electric aviation space to push forward the technology to facilitate a new type of air travel. And of course, the Jetsons is a great example of flying cars, and so our goal is to make that a reality. And what urban air mobility is actually thinking about travel, not just in 2 dimensions on the ground, but thinking about travel in terms of 3 dimensions. So adding the 3rd dimension of airspace, which ultimately will very rapidly reduce the congestion that we see on the ground as one potential mode of transportation. And since this is a commercial proposition, you do have to have a business case. And there have been many studies looking at the urban air mobility use case, both for passenger transport as well as cargo logistics, and it's a relatively large business opportunity happening the next 10 to 20 years, which goes well over $1 trillion. So in terms of entrepreneurial ventures, being able to raise capital to support these aircraft developments from the engineering perspective, as well as the full certification, is kind of key to making that a reality. So I think I included a video, which I will briefly talk over. We are doing a fully electric, emission-free tilt-wing aircraft. So there's many different ways that you can facilitate the ability to take off and land vertically, which allows you to land in urban locations. But we also have a wing which functions as a traditional fixed-wing aircraft, which allows you to be more efficient during cruise. So this is one implementation. There are other companies who are offering different implementations. What you can see is an aircraft which is essentially an air taxi, which means that it carries 4 passengers as a regular taxi would, and then with a pilot. We are designing for autonomy, but we're still many years away from the FAA approving fully autonomous flight operation. So therefore, having a pilot in the loop makes sense from a safety perspective for a whole range of different use cases that you could potentially use it for. And in case you're curious, the video has the aircraft flying over Detroit in the background, which is where you can see the GM towers. So one of the things that people who aren't pilots aren't aware of is that there's actually quite a few general aviation airports across the country. In the vicinity of LAX, which is the international airport in Los Angeles, there's about 5. In the vicinity of Detroit, where our company is located, there's about 5 to 7. And those existing infrastructure assets are primarily used only by general aviation pilots, which means that they're very much underutilized. So being able to come up with an alternative platform, which doesn't require a long runway, as is the case of most jet aircraft, means that you can utilize these existing infrastructure assets as a means of providing city to city center travel and potentially regional travel as the aircraft are able to improve their range over time. But one of the big challenges for any form of transportation on the ground is the acquisition of land, is the right of way, is the cost associated with literally laying tracks and railroads and bridges. So being able to do something in the sky where it doesn't have an infrastructure aspect can allow you to have a path to market, a path to use relatively quickly, which is one of the arguments for urban air mobility. In terms of the platform that we're developing, you can see it here. It has a very attractive looking appearance because we have industrial designers who work on sports cars, but ultimately ultimately attractive aerodynamic design couples to more energy efficiency. And one of the big challenges of electric aviation is that batteries are quite heavy, which one of the speakers alluded to before, which means that you're very range limited. So for the initial aircraft that you'll see globally that are coming out, which are fully electric, they're limited to less than 100 miles of range, which means that only certain use cases can use them. And one of them is urban travel, urban to suburban travel, and then some close city pairs. And of course, anything related to emergency response, medevac, and high-value cargo logistics. But just as we've seen an improvement in battery technology over the course of the past decade because of additional use for electric vehicle drivetrains on the ground, that same improvement will allow these aircraft to eventually travel even longer distances. And of course, the goal is to have sort of regional travel on fully electric aircraft. In the meantime, you could have hybrid electric aircraft. And in terms of what we're doing as a company, we are trying to leverage the existing automotive sector, both from the electric vehicle drivetrain perspective, as well as from the mass production vehicle perspective. And one of the things that we were talking about a little bit earlier is that if we do see an increase in low altitude airspace traffic with urban air mobility, we will eventually need to have an update to air traffic control to support the higher densities of traffic. And there is a good analogy between V2X connected vehicle technology, which is used for self-driving vehicles on the ground, which could be used by these aircraft in the low altitude airspace. Moving forward, in terms of what this particular vehicle can do, it can carry 4 passengers and a pilot, or it can carry a passenger and 1,100 pounds of cargo. And so there are many different cargo use cases as well as emergency response use cases, which this would be an alternative for when you compare it to a helicopter, for example. And these type of aircraft, both from an operational perspective as well as a unit cost perspective, will be far more affordable. So what does that mean to you as the potential urban air taxi traveling public? We're designing the vehicles to facilitate a price point which would give you roughly a trip from a suburban airport to a major airport for $75 per seat, which is very similar to an Uber ride. So the intention of the customer base for the service wouldn't be just for executives of XYZ company, it would be for the full-on business traveling public as well as people who are trying to get across congested urban centers moving forward. User experience, these aircraft are not jet aircraft. They're flown in low altitude airspace, so between 1,000 to 3,000 feet above the ground, which means that you actually have a very nice view. So I'm not sure if any of you are sort of private pilots or instrument rated pilots in the room, but when you're flying at 1,000 to 3,000 feet above the ground, it's actually a really fun experience. It's quite different from commercial aviation where you're kind of stuck in the cattle car. So this would be very comfortable and roomy and a nice way to go. In terms of what we're doing as a startup is we're developing the vehicle from scratch. We've built many subscale aircraft. The largest one we have is built is 1/3 scale that you see here that they demonstrated over at the Uber Elevate Summit a few years back. And because these aircraft are fully electric, they have to be lightweighted, and our aircraft is 100% composite. So lightweighting allows you to be more energy efficient because you're carrying less payload in terms of your dry mass. This also couples to a ride-sharing platform, which is being developed by different providers. Probably the most famous one is Uber Elevate, but ultimately this form of transportation couples to the mobility as a service revolution that we see going around, whether it's car-based transit, and then hopefully, of course, we hope eventually air-based transit with urban air mobility systems. And so I think we're going to take the next 10 minutes, or I guess 15, 20 minutes, taking questions from everybody. Thank you.
Great. Thank you. Questions are, well, I wait for the audience questions. I'll start. I'll start with maybe a question for each of you, kind of in sequence, starting with Norm. Given where your project is today, what is likely to be the single one or two biggest challenges to seeing it kind of fully adopted?
The first couple of challenges with this concept is we have to get a large number of electric vehicles on the road, because putting in massive infrastructure to power them on the road requires about 70 to 80% of the vehicles traveling to be electrified. So you need to get a base level put in, which is going to take 10 to 15 years at least. Once we've done that, we need to go through the couple of, I saw a couple surprises about that. I think it's going to be adopted a lot faster than we think. Because we're going to start finding issues with petroleum once you get 50% of vehicles converted to electricity. and that will drive us over. The last half will take not nearly as long. The second issue is we do have some technology changes, and I don't know whether batteries are going to become so cheap and so light that you don't build the infrastructure, or whether you get hung up in battery development and you have to move to a different kind of infrastructure in order to move all the way. So those kinds of technology changes are important.
Great.
Same question. For us, it's timing. I mentioned the approvals that we need from the Federal Railroad Administration at the US DOT. You know, if those two approvals are on pace for this summer, we start construction and you're riding the train in 2026. Then it becomes a logistics challenge because we've got to build 240 miles. We'll build it all simultaneously, 10 different segments. Workforce keeps us up at night. You know, materials availability keeps us up at night. We've got great partners, but the logistics of using, you know, 3 times the amount of concrete that went into building Hoover Dam, getting it in the right place at the right time when it's not 102 degrees and you can actually pour it, all of those logistics are going to be a big challenge.
Okay, great. Joe, absolutely.
So top two, I would say, are technology and adoption. So on the technology front, of course, building autonomy software is hard. Norm told me that the first time I met him, a couple of minutes into our conversation. And that is a difficult thing because people are unpredictable. The vehicles that we've had out on the road, as you might imagine, when people see them for the first time, they sometimes decide to gawk, sometimes they decide to take pictures, and all while they're driving, so not the safest situation. On the adoption front, our goal is to drive down the cost of delivery to the point that it's essentially free. But what that does mean is that people are going to their curbs to retrieve their own items. There's a joke on Twitter that is quite apt to our company, which is, on one hand, people are so lazy that they don't want to go to the grocery store anymore. On the other hand, like, what the heck, I have to go to the curb to get my stuff, right? So there is a thread that we are essentially trying to balance on.
Okay, great. Nita?
So for us, on the technology front, it's definitely batteries. So the better performance improvement we can get in batteries from a specific energy perspective is really important. And then, of course, the stability of those batteries from a safety and reliability perspective. Because unlike a self-driving car where you can stop and pull over with an aircraft, obviously you have to have enough energy to come in and land safely. So that's a challenge on the technology front. And then I think the bigger one, however, is public acceptance. Because for a lot of people, when they think of personal air travel, they think of it for the rich and famous, you know, flying around in helicopters in Monaco. So the whole point here is to drive down the price of these vehicles so that we can have something which is affordable for everybody and then people being comfortable actually using that as a service.
Great, okay, thank you. So we'll move to the audience questions. And the first one is for Norm. Can our electric power grid keep up if massive numbers of people buy electric cars and charge them at home at night or at other locations?
The question about the electric grid, the amount of volume of energy volume that we have to add in order to electrify the fleet is not that much. It's about 10 to 15% of the total electricity generated today in the US. So it's not an insurmountable amount of additional power that needs to be done. The question about whether I have enough power delivery capacity to charge at night, the answer in most cases is we already have that in place. But there are some, because of peak demand for power in Texas is during the summer, in the air conditioning peak in the afternoon. So if you're charging at night, you probably have plenty of wires to deliver that power existing. If not, CenterPoint and others have plenty of means of putting that in. The issue is, as we move more toward renewable energy, which is intermittent and comes during the summer peak sun time if it's solar, or in the evening or night if it's wind, we need some battery technology in order to provide that during the middle of the drop when we don't have renewable as available. So that's also another technology that's going to demand battery support to stabilize the grid.
Okay. The next one is for the entire panel. Well, maybe we'll start at the other end here with Anita. In your opinion, what's the single most effective policy or market incentive to accelerate EV adoption? We're all talking about effectively different types of electric vehicles. So I think it's relevant for all. What do you think is the most single policy or market incentive to accelerate adoption?
I guess I have a little bit of bias too here because I want to see a shift over to renewables. So I think governments, whether it's at the state level or at the federal level, mandating timelines to get to fully renewable energy supply, because that then couples to a more efficient energy source to get your electric vehicles going. So that would be number one thing, is getting us to 100% renewable by X decade.
I certainly agree with that. I think that will definitely be sort of the bottom. At the top end, of course, is that the vehicles have to be attractive, they have to be well priced, and they have to be competitive with what exists today. And so I think from the policy perspective, the most that the government can do is essentially mandate this floor. But from an incentive perspective, people really have to get what they want from the vehicle to adopt it.
For us, it goes back to the timing of the regulatory process. And businesses want certainty. And if you're going to tell me yes or you're going to tell me no, just tell me when you're going to tell me. And I can live with that. And so I think that would be, making sure that it is a full process, but putting some certainty around the timing of it.
For me, I have a different view. I think that our best regulatory approach that we can take is to implement a carbon fee and dividend policy that provides for a huge amount of innovation, but make sure that everybody who's polluting with fossil fuel emissions is paying the price. And by doing so, we're going to raise the attractiveness of renewable and electric vehicles, along with everything else that we can do to protect climate. That's what our ultimate objective is to make sure we have a habitable world.
Okay, well, we'll shift a little bit, slightly to autonomous vehicle and autonomous vehicle infrastructure. And one of the questions is, how will we ensure cybersecurity with this future autonomous vehicle infrastructure when you think about all the aspects of it, the vehicles, the signaling, the charging stations, and all of that? Nina, we'll start with you again.
Well, I'm not an expert on cybersecurity protocols, but it certainly is super, super important. Otherwise, there's potential for terrorist incidents and things like that. So unfortunately, I couldn't speak to you as to what the solution is, but it's a really important one, and it has to be coupled from a regulatory side as well as a technical side.
Okay.
Yeah, if she's not an expert, I'm definitely.
Okay, you can pass.
Well, I don't think I'm an expert either. For us, it's multifaceted because it's the systems that are communications within the operations of the railroad, as well as then when you are a passenger on the railroad and you're connecting via 5G at this point and doing all those kinds of things, or it's a secure transaction when you're purchasing your ticket. And our real view is, somebody said mobility as a service earlier. You as a customer will want us to get you either from your desk to your desk or your couch to your couch, not the station to the station, and making sure that not only are our systems secure, but those interfaces with, rideshare, with rental cars, with whatever your last mile solution is going to be, is seamless and safe as well.
Yes. I'm going to pass.
Okay. This is specifically for Holly. A couple of questions. One, what will the load be on the grid when the train's moving at 200 miles an hour? And it's full?
And it's what?
And it's full. The train is full.
So it's at 125 kilovolts, and my handy-dandy engineers gave me the exact amounts that I'm going to look at because they think they're funny and they give me examples, but they don't give me numbers sometimes. And so when we are at our acceleration, we'll be at 12 megawatts, and when we're cruising at 200 miles an hour, then I think it was actually on the slide earlier, and it's going to be at about 6.
Okay. Another question for you, maybe a little bit more practical. What will the cost of a ticket be?
I've gotten that question before, strangely. So one of the things that we know is that when you go between Houston and Dallas, 90% of you drive. So our market is cars and getting folks out of their cars into a cleaner alternative. And so we will price competitively with vehicles. We know that we will get the market share of flying just because we'll be faster, more reliable. So you think our pricing will be from less than $100 to less than an airplane ticket, depending on, and it'll be dynamic pricing like a hotel. What's going on? Did you just walk up and buy a ticket at 7:30 on Monday morning, or is it off-peak Tuesday afternoon and you bought it 2 weeks in advance? So it will be dynamic, and in 6 years, it'll be competitive to those.
Okay, we'll shift back to a kind of higher level question for the whole panel, maybe start with Norm. The question is, with a statement first, electric vehicles are not without pollution. It's just shifted to power plants which aren't that efficient, and many are coal-fired. Isn't this just externalizing pollution and straining overload on power systems?
That's a common myth. The issue is, an electric vehicle is exceptionally efficient at using the power that it has. So once you get the power to it, the question is, where did that come from? In the Texas grid today, about 30% to 35% of it is non-carbon emitting. 20% of that is nuclear. The other 20% of that is solar and wind. We're increasing wind. In fact, I just heard a presentation that said the pipeline of new projects coming into ERCOT, the grid that we have here, is 100% renewable, and it's enough to replace everything that we already have. So there's plenty of opportunity to put that in. The rest of the grid that we have in Texas today is about 40% gas and about 20% coal, 25% now. Coal is declining. Even with a coal plant, the stationary coal plant runs at about 40% efficiency. Stationary gas can run at about 80% efficiency. Your average internal combustion engine in your car runs at about 15% efficiency. So even if you use electricity from a large fossil fuel plant, you're going to emit less if you have an electric vehicle in every circumstance in the US today.
Okay. This is an interesting question. I'm sorry, that was actually for the whole panel. Does anybody have anything to add to that?
I was going to say what he was going to say.
Exactly.
I guess what I would add to that, though, is that, but it is a good thing from a policy perspective for us to be able to shift over to being 100% renewable, because we just get an even better bang for the buck. We become even more efficient. So I think those
we're
things
moving
should
that
go
way
hand in
very
hand.
rapidly, actually.
Okay, this is an interesting question. The presentations were very urban-centric. How is rural America best included in this revolution and not left behind? Let's start with you, Nina.
So I did do a panel last year about how you can use new modes of transportation to connect urban to suburban to rural, because there are many goods and services that people in rural America or rural communities around the world have to go to urban centers for. And so the big challenge is right now, if they're limited to car travel, that's quite difficult. So urban air mobility does have a very specific use case to be able to get people at relatively fast speeds across large distances on the order of 100 to 200 miles, which would cover both rural centers relative to a city. So this is a very useful use case for it.
Okay.
Yeah, absolutely. So I didn't walk through all of the use cases. We're mostly focused on suburban environments. It just so happens that the areas that we've started are in the urban density, so they exist within the city of Houston, but are fairly suburban at a second blush. For rural environments, what we look to provide is the ability for folks to get whatever goods they need from their provider, and that for us means in the long term getting to a place where the vehicle, whether it is a suburban or a rural environment, can connect, or the provider can connect to this local platform and deliver to their customer. So whether that customer is 2 miles or 20 miles, we wouldn't be able to make the delivery.
Okay.
For us, it's a bit unique because we are building this massive infrastructure project. But think about this. When you build a high-speed train, it's roughly the width of a county road. And when you want to move more people because of the exponential growth that Texas is experiencing, you just run the trains more frequently. As opposed to building a highway, expanding lanes, access roads, development, rinse and repeat, and getting more and more entrenched, using more and more land. And so this is the most efficient and cleanest way to move the most people with the least impact. And I think we will need to do this more frequently over time to make sure rural Texas stays rural, frankly.
I want to speak specifically to those folks who live in rural areas who like to drive trucks, pickup trucks. Please wait 2 years. Okay? Ford, GM, Atlas, Rivian, Tesla will all have models available for you to purchase. It will be a little bit more expensive than the Platinum F-150 you were planning to buy, maybe. Might be the same price, but you will pay 1/4 the amount of cost to fuel it, which every truck driver that I know moans about the cost of filling up their pickup. There is no difference if you live on a farm or if you live in town. Those pickups will provide utility. The beauty about living on a farm, you probably have some space where you could set up your own solar and you could produce your own power for a lot less than what you're paying the rural co-op today. So to me, it seems like a great opportunity for rural people to go electric and enjoy the benefit.
Okay. A slightly different question, but quite interesting, actually. Good evening. I am a student here at the university with a growing interest in doing research. Unfortunately, despite this interest, I don't know what question I would like to answer. So I would like some inspiration. Obviously a student and not a faculty member. What are 2 problems each of your teams have faced while exploring energy innovation? And what are some of the positive and negative effects of your or your competitors, if you want to put it that way, proposed projects? Start with her. Holly, we'll start with you.
Start with me, oh gosh. You know, it's a drive to be, the biggest challenge is the drive to be ever more efficient, right? It's a lighter train, it's a more energy efficient train, it's improving upon the regenerative braking, it's putting battery backups in the train so if there is an issue, you can make it to the next station. Our teams, you know, I have to say, we've got a really great partnership between our teams and CenterPoint and the other energy companies, but I think it's going to be, how do we make sure that all of that is seamless? I'm not sure that exactly answered that question, but I think the study for us is going to be more of a human behavior study as opposed to an energy study.
Okay, okay.
Sure. So 2 issues that we've run into. One that's essentially kind of solved itself a little bit for us. And the second that, if you're looking for research topics, might be a good one. The first is because our vehicle is lighter, narrower, smaller than your standard vehicle, the trade-off between essentially the battery size and the amount of load for essentially like dry mass was less difficult than if we were essentially putting this in a Tesla or in a new Rivian truck. And so that kind of resolved itself. The second thing is, of course, we want to squeeze out as many deliveries as we can from the battery when it is charged. And for us, that is a bit of a logistics and operational question. So this idea of local commerce is not just about sort of a talking point and good for us to do this, but it actually makes a ton of business sense. If we can essentially have the bot go from Kroger to someone's home, to Shipley's, to someone else's home, to to Torchy's, and then to someone else's home, each of those deliveries actually squeezes out just a bit more efficiency of the battery of the bot that we've charged. And so the more that we can do that, the more efficient we can be, the more deliveries we can do, the more money we can make. So if you've got a great solution, we are hiring.
Okay.
So maybe I'll answer the first question first, just because I'm a professor and I deal with students all the time, undergraduates and graduate students. So I think it's really important to find something that you feel passionate about. And I think if you're passionate about technology, look for technologies that will solve problems, like solve society's challenges, as opposed to technology for convenience, because I think you could feel more passionate about it and you can impact more people across the world. And there's just so many things you can come up with in that area. And I would say for us, our challenges oftentimes revolve around the fact that we're a really tiny company. We have very few people. We're a startup. I worked for the government for most of my life, where you've got everything available to you from an infrastructure perspective and everything from a talent pool perspective. So when you're a tiny company, you have to choose really carefully as to who you bring onto the team. And so one of the ways to solve that is to partner with other people who have that expertise, so that you can focus on something that you're good at and you can make use of the much larger industrial space. So we literally, as of yesterday, we had our press release, we partnered with Spirit Aerostructures, who's an enormous aerostructures provider. So they're going to help us as a little company learn more about the FAA certification process. So, but our biggest challenges oftentimes are related to the size of our company.
Okay. Norm?
I think for us, in the many different startup companies we've had dealing with issues related to how to combat climate change and deal with energy, the number one thing is leadership. So you can talk about all the technology stuff. There's clearly a huge number of problems with that that are going to be exciting to work on. But what's most important is to lead with your talents, lead on persuading people what to do, and get on the challenge.
Okay. Got a question here for Anita and for Shola with regard to autonomous vehicles specifically. Do you see the vehicles being more of a taxi Uber system where 90% of the cars are owned by companies for rent, or more like today's car ownership model where 80% of vehicles are owned by people?
Yeah, that's a great question. We've actually looked at both models. In the short term, because of the maintenance and the issues, most technicians and mechanics that you would take these vehicles would have no idea what to do with them. What makes the most sense is for us to sort of keep this in-house. But in the longer term, there is a question of what could make sense. So we are open to those.
And so for the urban air taxi model, the mobility as a service model, ride-sharing model in the sky, the aircraft would not be owned by private individuals. It would be owned by operators. And so those operators would be the ones providing the pilots, most likely doing the maintenance, operations, refueling, in this case, batteries. And then people would simply ride that service. So we don't really envision a use case where we would sell directly to a private individual, with the exception of governments, fire departments, and private companies.
Another question, and it was originally addressed to Shola, but could conceivably be addressed to others, with the possible exception of Holly here. How do we address the loss of jobs that autonomous vehicles create, and the lack of relationships by not putting a human face to a business? I think that was where the
Yeah,
came
absolutely.
to you.
And that's a great question. So a lot of the partnerships that we had today have come from us going out and saying, hey, we are really interested in providing delivery services for you. Would you like to have a conversation with us? Domino's, I think, is a great example, where we were at CES and they walked up and they said, hey, we have over 20,000 open delivery driver jobs. We can't fill them. And the problem with most of these jobs is that 7 o'clock on Friday, we need all 20,000, but at 11 o'clock on Wednesday, we really don't need any of them, right? And so if you think about what's occurring now, most of these services either are so prohibitively expensive that they aren't used that much, or they are very, very seasonal and sort of have their peaks and troughs. And really that allows for us to fill in what is a gap that people really don't even think about. The second part of this is that we are hiring, and we think of this a bit of as a cottage industry. Autonomous vehicles are coming, and they are coming to stay. And the mechanics, the safety operators, even the folks, so Kroger, Walmart, Domino's, have all hired people to load these vehicles, and that has been a large part of where we have seen this growth in employment. So I don't think of it necessarily as a loss of jobs. as much of a shift, right? I think we will see this shift. Some of the jobs will be much better than the ones that were left behind. Some of them we don't even really sort of think of as existing today, but will exist in the future. In regards to that relationship between businesses and their customers, that is something that we are very cognizant of, and we work really closely with our partners. Many of them, particularly Domino's, really loves being the face and having and interacting, and we don't have a problem with that. Our goal is essentially to make the delivery happen. There are ways and means that we connect, whether it be someone from Domino's or our own personal support team, with someone who's standing at the other end of a bot. So you might lose the face, but you're not going to lose the interaction.
Okay, great. So we'll just like to have a short wrap up here. Give each panelist 20 or 30 seconds to summarize, help the audience understand perhaps some important things that maybe we haven't touched on or anything like that. So we'll start with Norm.
Okay, so thanks, Greg. Thanks, everyone. It's been really a pleasure to be here today. So the interstate touches everybody's life in the U.S. very frequently. Here in this room, almost daily basis. It's a great and wonderful infrastructure investment that we've made over almost a century. And we need to continue to make it even more relevant as we go forward. We have to make it climate proof, which means we need to remove petroleum from its power of propulsion and go electric. And we need to take advantage of other technologies that we have coming out to make it safer, faster, cheaper. And we can do all of that. We're going to see it unfold over the next 15 to 30 years. It's going to take some time, but we can see a pathway of continuing to use that massive investment and make it even better for our country.
Okay, Holly.
I would just say stay tuned, stay engaged. There's a lot of milestones that are going to happen this year, and we look forward to putting a bunch of people to work, to saving a bunch of lives, to helping with the effects on the climate, as well as to delivering you safely back and forth in between Houston and Dallas, where I always have to remember where I am, which means you don't have to stay in Dallas. So I look forward to giving you a ride.
But you could stay in College Station. Joel.
Absolutely. So it's wonderful being here this evening. Our vehicles, you may see our Prius vehicles that are doing testing out on the road. We're quite excited for R2 to hit the roads. A major proponent, and I don't think I really spoke about this quite a bit, is the safety aspect of this. So our vehicle is slower. When you see it, you can wave to it for quite a long time because it goes that slow. And the goal is safety, right? Like we want to be able to very conveniently, safely deliver people's goods, take on their errands, and we think that it is the future.
So thanks to the wonderful work by all my panelists here, most ground-based transit is becoming fully electric, which is fantastic, which means that right now, even though aviation actually represents a pretty small CO2 output, it's going to become a huge CO2 output if we don't do something to fix that. So urban air mobility with its short-range use case actually kickstarts the electric aviation revolution, and from that, with better batteries and eventually hydrogen fuel cells, air travel can be fully emission-free in the next 10 to 20 years.
Great. Well, I hope you've enjoyed the symposium. I think we've had 4 really interesting leading-edge projects that could have a big impact on the transportation revolution. And they're not just ideas. They're actual projects and products that are underway and in the process of being implemented. So hopefully you'll find it as exciting as I did. I'd like to thank all our panelists for coming. It's been very great. As always, thanks to Ramanan, U of H Energy, Centerpoint, our sponsor, and all the support staff at UH Energy, Lauren, and all the people at Houston Public Media for putting on such a first-class event. I wish I had this kind of support in my lowly Bauer event. Okay?
Thank you, Greg. And thank you to the speakers for your presentations. Our thinking is enriched by the insights you shared with us this evening. Anita, You're bringing us science fiction. I can't wait to ride in those planes of the future. It's amazing. Shola, I heard that you were so inspirational that there is now an autonomous vehicle, a neuro-inspired autonomous vehicle that's going to be at the reception.
Oh, wonderful.
Holly, I'm blown away by the way Texas Central navigates a complex multi-stakeholder environment to bring an incredible project to our region. And Norm, you already know what a big fan I am of yours, and I can't wait to get on those highways where I just drive in a lane and it charges my car. Really appreciate all these expert voices. And I also appreciate everyone who showed up tonight, everyone who decided that moving your region forward is important to you, important enough for you to show up on a Tuesday night and learn something about it and figure out what you can do about it. And you've heard these expert voices, but there's an expert voice that we still need, and that's yours, the voice of the customer. The voice of the customer keeps innovation focused on the right things. And a good example of how you can make that voice heard is if you go to Evolve Houston's booth out front, there is this survey, and you may have found it on your seat, and it's got what everybody's favorite thing, a QR code. Who doesn't love a good QR code, am I right? So my dad asked me, what the hell do I do with a QR code? And I told him that you can actually just use your phone. If you open up the camera on most phones and just use your camera to look at a QR code, it'll probably pop up your browser window, and you can just navigate that way. This will take you to a survey where you can tell Evolve Houston what you would like to see for electric vehicles, and that will help move our region forward. You can also go to the reception after this and talk to all of these experts and let them know your ideas and what it is you'd like to see, and that will help move our region forward. And if you haven't test-driven an electric vehicle already, come find me. I've got a stack of business cards. And if you come get a business card from me and send me an email saying that you want to test drive an EV, I will make sure that that happens. So thank you again to all the speakers. Thank you to Greg, Dr. Krishnamurti, and the university. CenterPoint Energy is your trusted energy provider for any electrified transportation project you're undertaking. Thank you.
Cross them a lot.